Hello student, my name is Mr. Dhawale, Department of Chemistry, RBNB College, Sri Rampur. In today's topic, we are going to focus on rings other than 6-membered. Means what? We already discussed in last lectures regarding 6-membered ring and its reaction, its stereochemistry. In very brief, it contains so many different type of reactions which can give different properties, different stability orders. So in that case, we take a brief discussion regarding 6-membered ring system, but now we focus on the other than 6-membered ring system. What type of ring systems are present? Okay, so first ring is formed in suppose we consider in case of size of ring system. At that time we go for the number of carbon atom present in the ring, and at that time we can call what is the size of that ring. Okay, suppose here the number of carbon atom in 6-membered ring system is 6, so we call this is ring size is 6-membered ring. Okay, so such type of ring system is present in the 1 carbon, 2 carbon, 3 carbon, 4 carbon. Okay, so which is the first ring system? Okay, so first carbon atom doesn't form a ring. 2 carbon atom, when 2 carbon atom combines, at that time they doesn't able to form a ring. But when we go for 3 carbon atom or ring size is 3, at that time we have first ring system. Okay, so 3-membered ring system is first ring. So first one is the three-membered rings. Okay, so the planar structure of 3-membered ring system is somewhat like this. Okay, so this is the 3-membered ring system having 3 carbon atoms, and when we go for deep study, at that time we draw a carbon in all 3 positions. Here 1 hydrogen, here 1 hydrogen, another here 1, here 1. Okay, and these are not the actual position of the hydrogen atom, but we for our convenience we can try to write all these hydrogens are on the upper and lower side. Okay, here I am squared these 3 hydrogens which are on the same side. Okay, so these 3 hydrogen atoms are present on the above the plane or beta side. Okay, so you remember, all suppose this is a plane, at that time 3 positions of hydrogen atoms are on the same side or beta side, and remaining 3 hydrogen atoms which are circled are present on the alpha side. Okay, so here we can understood about the strain. Okay, so in 3-membered ring system, here much amount of strain is present in that ring. Why? Because this is very small ring system, and at that time that bond angle is very small, so that it can be highly strained in such a type of cyclic form. So here that type of angle strain is very much. And also another one strain is there, which one is eclipsing strain. Okay, eclipsing strain means what? When 2 protons or 2 hydrogens are present on adjacent carbon are in and it contain a diagonal angle, and that diagonal angle is 0. At that time both hydrogens are very close to each other in on the adjacent carbon atom, and due to the presence of closeness, it can be, or we can say they can interact with each other very high content, and they repel each other, and at that time that structure is much strained, or the structure is highly unstable. Okay, so in 3-membered ring system, eclipsing strain is one of the major and predominant strain. So that we have 2 type of strain in this case. Here one is the torsional strain, and or it is also called as the angle strain, and second one is eclipsing strain. Okay, these two strains are present in three-membered ring system, but predominant strain is eclipsing strain here. Okay, and when we go to the in the model of the three-membered ring system, at that time we see here the bonds are not straight. Suppose we try to show here these three carbon atoms, but these bonds we represent here, these are the straight line bonds. Okay, but in actual condition these bonds are bent outward. Okay, and so the electron density of the bond is accommodated at the outside. Okay, outside the bond. Okay, so suppose we try to draw the electron density here. Okay, so this type of orbitals we try to show here, and at that time you see here actual the electron density of this carbon-carbon single bond is accommodated at the outside to this bond. Okay, so you remember this is somewhat like circular shape, and due to this the angle strain is somewhat released due to the bent shape bond, and these bonds are nothing but the banana like bonds. So we write here banana like bonds. Okay, and due to this bent shape bonds, some strain of this three-membered ring system is somewhat released, and that's why here the angle strain is less predominant than that of eclipsing strain. Okay, so you remember this one, and here this is the actual structure of three-membered ring system, and here this carbon atom and angle strain is calculated by using the actual angle which can be reduced from, or which can be less from the tetrahedral angle, and tetrahedral angle is nothing but the 109.28 degree. Okay, minus, suppose its angle is 72 degree. At that time we have such type of calculations, and we got some different values, and suppose here we got any value. At that time you say this is the angle strain. Okay, why? Because why we choose this value 109.28 degree? Why? Because the carbon atom which can accommodate, or the angle between the bond present on the carbon atom, these four bonds having 109.28 degree angle. Okay, so you remember, and this bond is highly stable bonds, so that bond angle is also stable, and if the angle is changed, if the bond angle is changed, at that time much strain is present on that carbon atom, and that's why stability is lost. Okay, due to the increase in angle or decrease in angle, it can be lose its stability of the carbon atom present in the structure. So that here in this case also three carbon atoms are there, and all these are the sp3 hybridized carbon atoms, but here the angle strain is less than that, and it is much less. Okay, but when we go for triangular shape three-membered ring system, at that time the actual angle is in triangle is only 60 degree, but now here we calculate this is the 72. Why? Because the angle is not actual in triangle, which can be increased due to the bend shape of the bonds. Okay, so you remember such a type of angle strain is present in 3-membered ring system. And when we go for next type of ring system is 4-membered ring system, and 4-membered ring system contain, here suppose we go for 4-membered ring system, this is 3-membered, and now okay, here we write 4-membered rings. In 4-membered ring system also, as like we seen in 3-membered ring system, there are also 4-membered ring system. In 4-membered ring system, when we see the structure of 4-membered ring system, this is somewhat square like structure, and when we try to clear cut structure of the which having carbons, this type of structure we have seen. Okay, these are the protons. Okay, suppose these are the hydrogens present on that 4-membered ring system. Okay, and this is the structure, and having also 2 type of strains. Which 2 type of strains are there? First one is the angle strain, or we call this is the torsional strain, and in another case it has also eclipsing strain, and eclipsing strain is also major one. Okay, so the predominant strain present in the 4-membered ring system also is the eclipsing strain. Okay, and also it contain bond angle strain, but that bond angle strain is less affect on the stability of that 4-membered ring system, so that we can doesn't calculate, or we can ignore that as compared to eclipsed angle strain, eclipsing strain. Why? Because here 8 hydrogens are there, and all these hydrogens are present in planar structure in eclipsed form. Okay, so 8 eclipsing strains are there, and that strains are much higher than that of angle strain, so that eclipsing strain is much greater effect on the stability of 4-membered ring system, so that we call eclipsing strain is one of the predominant strain than that of angle strain. So here also that bonds are somewhat bent like this one. Okay, so that the bond angle between this one carbon atom having 2 bonds in ring system, and when we calculate its bond angle, at that time we have that bond angle is not 90, it can be more than 90, and it is nearly equal to 100 or less than 100 degree, but that is lesser than that of 109, so that here also some amount of angle strain is present in this type of ring system. Okay, so but this is the planar structure, and when we go for its puckered structure or butterfly structure, okay, this is another structure having such a type of puckered bonds are present, and at that time these bonds, these eclipsed bonds are tilted towards outside, and at that time distance between these 2 hydrogens in eclipse form they are very close to each other, but now these bonds are very away from the actual position. That's why distance is greater, and they doesn't interact with each other, and that position is one of the stable position in this case. So this is the puckered form, and puckered form is more stable than that of planar form. Okay, so you remember in case of 4-membered ring system, planar form is much stable than that of corresponding puckered form is more stable than that of the planar form. Why? Because the eclipsing strain is somewhat released in puckered form as compared to the planar form. Okay, so you remember this type of 4-membered ring system is here, and here 8 eclipsing strains are present. Okay, so and next type of the ring system is 5-membered ring system, but that ring system we will see at next lecture. Thank you.